A slow explosion, the violent birth of the Geminid meteor shower. The Geminids are one of the astronomical highlights of the year, creating a spectacular show of shooting stars every December. Scientists are now starting to understand where they came from. It was a time of great upheaval. The Roman Empire was in chaos after the assassination of Emperor Severus Alexander, while China was in turmoil following a string of wars. Far above the heads of these human machinations around 1,800 years ago, however, another dramatic event was unfolding, the effects of which we can still see today. Scientists think that around this time, something catastrophic happened to an asteroid called 3200 Phaethon, causing it to crumble and fling bits of debris into a long ring around the Sun. Every year, our own planet barrels through this cloud of debris, producing one of the most impressive meteor showers at the Geminids. Look up on a clear night in mid-December and you might catch a glimpse of them, streaks of light tracing across our sky. These are particles of this asteroid being vaporized in our atmosphere at speeds of up to 79,000 miles per hour, 127,000 kilometers per hour. The Geminids are particularly notable for the range of colors they produce, including yellow, green, and blue, says Tom Hennett, an astrophysicist at the Czech Academy of Sciences. They are also very bright, with up to 150 meteors visible to the naked eye every hour. You usually see nice meteors, says Henne. But the Geminids are also unique for another reason. They are the only known meteor shower to originate from an asteroid. All others come from the icy debris emitted by comets as the Sun blasts material off their surfaces. Asteroids, which are mostly rocky, don't normally form tails in this way. Yet, in 1983, astronomers discovered 3200 Phaethon, a bluish asteroid about 3.6 miles 5.8 kilometers wide, that appeared to closely match the path of debris associated with the Geminids, which get their name because they peak towards the constellation Gemini in the sky. This discovery led to the probable conclusion that the meteor shower originates from this object. It's highly likely, says Henne. This also explains why the Geminids have such a broad range of bright colors. The particles that produce them are harder, says Henne, and have a broader number of elements compared to those from comets. Phaethon's orbit around the Sun is also very unusual, says Ryan Jones, a planetary scientist at the University of Manchester in the UK. It goes very close to the Sun, closer than Mercury, she says, down to about 0.14 times the Earth-Sun distance. So, it gets quite hot, up to around 750 C/1400 F. And this unusual orbit has given scientists some clues about how the Geminids were born. In March 2024, amateur astronomer Danila Milanov in Russia and colleagues modeled the path of the debris of meteors and the orbit of Phaethon, which today are slightly separated by about 20,000 kilometers, 12,000 miles. They found that 1,200 to 2,400 years ago the two seemed to intersect. We suggest a catastrophic event happened on this timescale that formed the meteors, says Milanov, although another study says the event could have occurred up to 18,000 years ago. Exactly what that event might have been is hotly debated. One possibility is the asteroid collided with another object and broke apart. But Wolf Kukier, a PhD student in astronomy and astrophysics at the University of Chicago who has been studying the Geminids, says this is unlikely because few asteroids are seen close to the Sun. This suggests there is a common mechanism that removes them, and asteroid collisions are rare. They definitely can't all be explained by collisions, he says. It could be that the extreme heat close to the Sun meant that few asteroids were able to survive. Phaethon, it seems, is an exception. Indeed, the preferred explanation for the Geminids is that Phaethon was nudged towards the Sun from the asteroid belt, perhaps by gradual gravitational interactions with planets like Jupiter. Then 1,800 years ago or so, its orbit carried the asteroid close enough to the Sun that the heat caused it to break apart. As asteroids get close to the Sun, they get hot, and that causes thermal stress inside the asteroid. The Wolf Cukier. In 2023, Cukier used data from a NASA spacecraft called the Parker Solar Probe to learn more about this process. Parker had surreptitiously observed another section of the Geminids debris stream in space in 2020. Using these observations, Cukier concluded that the Geminids likely came from a single violent event, rather than being a continuous release of debris like a comet. That event might have been a low-speed explosion, says Cukier. As asteroids get close to the Sun, they get hot, and that causes thermal stress inside the asteroid. If they get too hot, that stress might build up to a point where the asteroid fragments apart into a bunch of pieces. Another possibility is the asteroid broke apart because of its spin. Phaethon currently rotates once every 3.6 hours, which is really fast, says Qiqing Zhang, an astronomer at Lowell Observatory in Arizona, possibly a result of the Sun heating its surface and imparting rotational speed as radiation flies off the surface, known as the Yorp effect. In 2023, Zhang observed sodium being emitted from Phaethon, which could be linked to this process. It could have lost a bunch of its surface as pieces of it spun off, exposing fresh sodium underneath, he says. Researchers at the Johns Hopkins University in Baltimore, Maryland, suggest that Phaethon may still be losing tiny amounts of its surface every time it loops back close to the Sun. They say the blue hue of the asteroid is due to extreme heating during its closest approach to the Sun, which they estimate causes a microscopic layer of rocky material, iron oxide, and pyroxene to sublime it off its surface. An upcoming Japanese mission called Destiny Plus, set to launch in 2028, might give us answers. The spacecraft will fly past Phaethon, taking images of its surface. If the fast rotation idea is correct, you'd expect to see landslides and rocks flowing out towards the equator where the centrifugal force should push things off, says Zhang. More like this, alien worlds might not have a night and day. How would that change evolution? The biggest black holes in the universe, the Earth's deepest living organisms, may hold clues to alien life on Mars. Unraveling the mysterious origins of the Geminids will do more than just help us understand a spectacular annual light show. A little better, it can also teach us more about the solar system as a whole, says Minji Kim, a planetary scientist at University College London in the UK. It tells us meteor showers can form through multiple different mechanisms, says Kim. There are other asteroids also known to be quite close to the Sun, which suggests we might expect similar meteor showers to form in our future. It's expected that Phaethon will eventually fall into the Sun in 10,000 years or so, says Zhang, leaving only the Geminids behind. Eventually they too will be swept away by our star. Phaethon shows us how asteroids die, says Zhang. But for now, it means we are fortuitously placed in time to observe this meteor shower. We just happen to be in a point of time and space where Earth is flying through the Geminids, says Cukier.